Good morning, students. Today we are going to discuss about the implementation of K-nearest neighbor algorithm. So, as we learned earlier that how K-nearest algorithm works, in the K-nearest neighbor algorithm, it's a supervised machine learning algorithm, and mostly it is used to classify the data point based on the how its neighbors are classified, as we discussed earlier. So, just we'll take a quick glance and we'll move to the implementation. So, you can see this diagram here we have a red wine and the white wine available with us. So as per the chloride level and sulfur dioxide level, we are deciding it is a red wine or it is a white wine. So we got a new sample and now I'm trying to decide that this new sample belongs to red wine or a white wine. So I'm considering the nearest neighbor of this particular new data point, and if most of the neighbors are near to the red label, so you can see if I'm considering this, so if I'm considering four neighbor of this particular data point, so you can see here all the four neighbors belongs to red class. So definitely we can say that this particular new data point also belongs to red wine. So in the case of k nearest neighbor, we are classifying the data as per their neighbors. So this we have discussed already. So in today's class, we are going to discuss about the implementation of k nearest neighbor. So you can see here, first of all, what we have to do, as we discussed the earlier program also. First of all, we have to import all the libraries which are required for the implementation of your algorithm. So we have imported NumPy and Panda, which is a common library for most of the programs. And we are importing from sklearn, we are importing and train and test, because I have to split my data into training and testing. And I have to apply some of the pre-processing techniques. So we are importing pre-processing also. And as we are implementing k-nearest classifier, so I have to import classifier. I need to draw confusion metric, or if you want to see the F1 score or accuracy score or confusion metric, so you have to import all these libraries as per the requirement of your task. Now, first of all, we have to read the data set. So, what is our data set here? We are considering the diabetes data set, and using that data set, I want to know that a particular person is having diabetes or not. And this data set is consisting of some of the features. Okay, so you can see here my data set is consisting the features that person is pregnant or not, pregnancies, their pregnancies, their glucose level, their blood pressure level, skin thickness, insulin, and BMI. So we can use these parameters and their diabetes prediction function, their age, and the final outcome that person is having diabetes or not. So we have all these features available into the data set, and we are considering these features and we are trying to predict a person is having diabetes or not. So I will train my model into this data set, and whenever I'm giving new data point, I'm expecting the model to know that person is having diabetes or not. Clear. So first of all, what I have to do, I have to read the data set. So for reading the data set, I'm using pd.read.csv, and I'm reading the data set which is available in this particular location in my laptop. So I read the data set from there, and just I want to display the first 5 lines of the data set. So we are using dataset.head, and at the same time I want to know the length of my data set. It means how many rows, or I can say how many patient detail I'm having in my data set. So I'm using length of data set. So it displaying the all the features of your data set, plus at the same time it's informing me that my data set consisting of 768 rows. So this is the basic thing which I have to do to know about my data set. Fine. Now I want to know a little more information about my data set. I'm using a function dataset.info. So it will display in this way. So it is giving me the detail that I have certain columns available in my data set, and what is the data type of each column, that is also mentioned. So most of the data is columns are integer type, and there are two columns which is BMI and diabetes, which is of float type. Fine. And it has uses the memory of 54.1 KB, means my data set is consuming 54.1 KB of memory in the system. Fine. Now this is the basic information which I may need during the processing of my data. So I displayed everything on the screen. Now, whenever I'm taking a data set, there is a possibility there are some values which are zero. So if you can take a simple example here. Suppose your blood pressure is zero. there is any possibility a person, until and unless person will not die, the blood pressure level will never be zero. So you cannot accept such values in your data set. So if you are having your glucose or blood pressure level or skin thickness or PMI or insulin is zero, it is not acceptable. So what I'm doing, I'm checking in all these columns that zero is there or not. If it is zero, I'm replacing zero with mean. Okay, so we are just checking this. So we have taken one variable zero not accepted, and I'm considering these features into it. And now I'm taking a for loop which is going to check for every column that there is a zero or not. So I'm checking overall, and when I'm checking this, I'm considering that wherever we have a zero, that zero has to be replaced by NaN. NaN means not available. Zero, we cannot keep blood pressure zero. Blood pressure, if maybe there is a possibility you have not determined or you have not kept the value of blood pressure, that is okay for me, but I cannot keep blood pressure value zero or any skin thickness or BMI value zero. So what I'm doing is my zero value will be replaced by NaN. And after that, what I'm doing, I don't want NaN also. I want to replace with the mean. So this is a common step whenever you are taking any numerical data and if a particular value is missing. So to fill the missing values, you can find the mean or median, and then you can replace the missing value with mean or median. So here we are considering that we are using mean here. So I am calculating the mean. Okay, we are calculating the mean of all the columns which are available in this zero not accepted. And finally, what I am doing, skip n equal to true. I am doing, it means whatever changes I am doing, it should be permanent in the data set. So I'm using this, and finally I'm replacing all the NaN value with the mean. So what you have done, first you have replaced 0 with NaN, and then you are replacing NaN with mean value. Okay, so in that way you have replaced all 0 with your mean value. So this is basic pre-processing which we need to do for such kind of data set. Now I want to see in my data set still there is any zero value available or not. So you can see here now there is no zero value. Your zero has been replaced with mean value. Clear? Now I have done the basic pre-processing on my data set. Now I'm ready to build a model. So what I have to do before building a model, okay, so what I have to do, I have to split my data into training and testing. As you can see your data set, your first 8 columns representing the features, and the last column is representing the outcome or the label of your data. So these first 8 columns representing the input features, and the last column is representing the target features. So what I have to do, I have to split the data, training data, I have to split the target data as well as input data. At the same time, I have to split the data into training as well as testing, because some portion of the data I use for training and the remaining part I use for testing purpose. So what I'm doing here, I'm using I want all the rows of my data set. That's why I use here colon, comma, and what I'm doing 0 to 8. So it means what are my columns? My columns are present from 0 to 8, and whenever I'm doing slicing, it will not considering that 8 here, because it will consider from 0 to 7, which actually I'm expecting, because 0 to 7 is consisting all the features of the data set. So what I'm doing, I'm using my dataset.ilog index location I'm referring, and I'm taking all the rows from 0 to 8. It means it will take 0 to 7 all the column values. So this is my X. Okay, X is representing input feature. In the same way, I need Y. Y is representing my outcome. So my outcome, what I want only this column number 8. So just I'm mentioning here all the rows of column number 8. So I have splitted the input features and the target variable into different variables. Now I'm ready to split data into training and testing. So I'm using here xtrain and xtest, ytrain and ytest. Okay, so my xtrain is used for input features and ytrain is used for target. In the same way, xtest is used for testing data and ytest is used for target level of your test data. So I splitted the data, and I'm doing for splitting, I'm using function train test split, which is splitted into x and y. Random state we kept as 0, and test size I'm taking 0.2. It means my training will have 80% of data, and for testing I'm using 20% of the data, and the random state I'm keeping 0. It means how many times I'm executing the same code randomly it is going to select the same values, same rows only, so that it will not affect your accuracy every time whenever you're executing the model. So it is mandatory to keep some value for the random state, so that every time it is going to choose the same random values in the training split as well as in the test split, and you will not get the different accuracy after every run. So remember this. This will use for most of the models. So I'm not going to explain it again. Clear? Now what we are doing here, we are using a feature scaling. Our features, you can see here, whatever features we are having, their values are very much scattered, or the scale of the values is so much different. So I want the scale of these values in a smaller scale, or I want to transform into a smaller scale. Suppose I have a salary account and my salary is between 10,000 to 10 crore. So it's a big scale. I want to keep it down, and I want this into 1 to scale of 10. So that is nothing but transforming the data from one way to another way, so that I can fit my data into a particular scale. So I want to perform the scaling here. So for performing the scaling, we are using here standard scalar function. We are calling the standard scalar function, and I'm doing the scaling for training data as well as the test data. So I'll fit my model and transforming it, the training data as well as the test data, and keeping again the data into same X train and Y train. Okay. Now I have to I should know that how many neighbors I'm considering to get the to classify my data into different classes. So it's a very important step here, that how many neighbors I'm considering. So just now we have seen the example that I was considering three nearest neighbors. The same way you have to identify that how many neighbors are you are using to classify your data into a particular class. So the best way of doing this is you will find the length of your test data. Okay, you will find the length of your test data. You will find the length of your test data, and then you do the square root of that, and that will become your k value. So always the k value will be a odd value. So we identified the length of the test data. We did the square root of that. It is suppose 12. So I cannot take k as a 12. I have to consider k as an odd value. So I'm going to take k value as 11. Okay. So in that way, identify what will be my k value. Now I have to use the classifier. So I'm using here k nearest neighbor classifier, and I'm considering how many neighbors, 11 neighbors, because I got the value 12, and the odd value nearest to the odd value of 12 is 11. So I'm considering 11. As I'm using Euclidean distance function for calculating the distance between two neighbors, and whenever I'm using Euclidean distance function, I have to set p value equal to 2. So p is representing 2 here. It means I'm using here Euclidean distance metric. Fine. So in that way, I'm using the classifier. Now I have to fit the classifier for X train as well as for Y train. So I'm fitting my model for X train as well as for Y train. So I fitted the model. Now I want to predict. Now fitting of the model is nothing but I have trained the model on a train data. Okay, with labels. Now I want to check the prediction. I want to check the accuracy of my model, that how much training has been happened, my model is able to predict as per the training results or not, or what are the result for the test data. So I'm using the y prediction here for predicting the result. So I'm using classifier dot predict for predicting the result, and my prediction from and data set, where data set is available, data set is available in x dot x underscore test. So using this I'm predicting my model, and finally, I'm predicting the results. As for this, it's saying that the first data point belongs to one class, and the second data points belong to zero class, and so on. So this is my prediction results. Now I want to draw a confusion matrix, which is representing all true positive, true negative, false positive, and false negative. I want to draw a confusion matrix for the prediction predicted data as well as in the actual data. So y test is representing my actual data, and y predict is representing my prediction data. So I want to draw a confusion matrix for both, and I want to also find out the F1 score on FN score for test data and the predicted data. So you can see here, this is my confusion matrix. This is representing true positive, this is representing true negative, this is representing false positive, and this is representing false negative. And I am calculating the F1 score, which is having a formula. If you remember, we have a formula for F1 score, which is 2 into precision into recall divided by precision plus recall. So this is my F1 score value. Same way you want to check the accuracy of your model on the actual data as well as in the predicted data. So you can see here the accuracy of our model is 0.81, or we can say it is 81%, or approximately it is 82%. So this is all about your KNN. I hope it is clear to you. Thank you.